makes an architectural marvel to add to a country that already has more than its fair share of construction marvels towering over 500 m above. A gorge in southwestern China, the bridge called the world's tallest by Chinese state media. Did you know that China has earned the nickname infrastructure giants? This is not an insult, it is a testament to their astonishing pace of development, will reduce car journeys from around 5 hours to less than 2 today. Let's explore some of China's most incredible construction feats, particularly its bridges, that have left American engineers awestruck, from massive cable-stayed bridges to world record-breaking structures. China is reshaping the landscape of bridge engineering. Let's find out how they do it and why these projects are so innovative. Imagine standing on a bridge so high it feels like you are touching the sky. The Beipan-Yangong Bridge is located 565 m above the valley and below at 1341 m long. This engineering marvel is among the world's tallest bridges. Standing on it is a surreal experience. You're suspended in the clouds with the entire world beneath your feet. Building this colossal bridge was an arduous task. The engineers faced dangerous cliffs, strong winds, and dense fog. Each step of the construction process was a battle against nature. To anchor the foundations, the workers had to fix them to the sides of the steep cliffs. From there, they built the bridge layer by layer, overcoming some of the most dangerous conditions imaginable. Their determination transformed a seemingly impassable chasm into a vital line of communication connecting previously isolated regions. When China unveiled its plan to build the Bianjiang Bridge, many Western experts scoffed. American engineers predicted that it would take China centuries to complete the bridge. In a surprising turn of events, China finished the bridge in just 3 years. This rapid success left many astonished and silenced those who doubted it. One can't help but wonder how long it would have taken if the United States had attempted such a monumental task. The Guizhou region suffered from poor transportation and difficult terrain. This isolation had impeded economic growth and hindered development for years. In 2013, the Chinese government decided to change that by announcing plans for a world record-breaking bridge to join the provinces of Yunnan and Guizhou. This ambitious project promised to revolutionize the region's transportation network. The best American technology, building such a bridge would take at least 300 years. Some went as far as to say that China would need 3,000 years to complete it, but the Chinese engineers were not deterred by such mockery. They approached the challenge with a bold vision to create the world's tallest bridge, no matter the cost. Located in a canyon, the traditional method of bridge construction with piers was not an option. Instead, they opted for a cable-stayed design that could withstand the intense winds and rugged geography. The construction process was nothing short of revolutionary. The pioneering engineers created new techniques to assemble the 160-ton steel trusses, lifting them with precision. They used overhead assembly methods, positioning each piece with such precision that the bolts that had to be perfectly aligned. The intense winds of the gorge made each stage a dangerous operation, but the engineers pressed on. In addition to overcoming the strong winds, the team found creative ways to deal with the logistical challenges. The river below the bridge was impassable for traditional vessels carrying materials. So the engineers dismantled the beams into smaller sections, transported them by truck, and reassembled them on site, as if they were putting together a huge jigsaw puzzle. This innovation sped up construction, reduced potential damage to the bridge piers, and helped meet the tight deadline, but that was just the beginning. The cables supporting the Penang Bridge deck are made of one of the strongest materials in the world. With a compressive strength of over 1860 MP, this not only ensured safety. A robust design, the Beipanjiang Bridge stands as a testament to Chinese engineering excellence. With 250 feet long, the steel cables connecting the bridge towers could stretch from New York to Washington, D.C. The Penang Bridge is not just a transportation route, it is an epic feat in engineering. With 2 towering pillars supporting a platform that stretches for over a mile, this bridge can support an impressive 22,000 tons of weight, making it one of the most monumental bridge structures in the world. China's Beipanjiang Bridge is more than just an engineering feat, it is a symbol of triumph. It has not only transformed the transportation landscape in Guizhou and Yunnan provinces, but also silence international critics who doubted China's capabilities. Success proves that China can achieve the unimaginable, and the world was watching with a total cost of 1 billion yuan. And a construction time of just 3 years. This bridge stands as a symbol of China's engineering power. It has drastically reduced the travel time between Yunnan and Guizhou, cutting the journey from several hours to just one. The Beipan Bridge has become a beacon of hope for the people of Guizhou and a point of immense pride for all of China. It is a miracle of modern engineering that will stand the test of time. The Hong Kong-Zhuhai-Macau Bridge. Let's start with one of the bridge's most famous bridge in the world, the Hong Kong-Zhuhai-Macau Bridge. The impressive bridge connects Hong Kong-Zhuhai and Macau, crossing the waters of Lindinyang at 55 kilometers long. It holds the title of the longest sea bridge in the world, but it is more than just a bridge. It is a combination of an island bridge and a tunnel. To allow the bridge to pass through busy shipping lanes, the engineers created a 6.7 kilometers underwater tunnel. Each section of the tunnel weighs 80,000 tons approximately, the same as an aircraft carrier. How difficult is it to install such a tunnel? The alignment between each segment of the tunnel must be accurate to within 2 centimeters. This is especially tricky in deep waters with strong current, sediment, and high pressure, making accuracy almost impossible. But thanks to the expertise of Chinese engineers, this complex project was successfully completed, impressing the world. Let's explore the process in more detail. There are 4 main methods for building underwater tunnels: the drill and blast method, the machine boring tunnel, the shield tunnel, and the submerged tube method. The drill and blast method uses explosives to excavate sections of the tunnel, removing the debris and lining the tunnel walls. It is generally used in stable geological areas where the blasting does not harm the surrounding rock. If water seeps in, the engineers inject tailings to seal the tunnel. China's first underwater tunnel, the Xiamen Tunnel, was built this way. The machine boring and shield tunneling methods both rely on large machines. Tunnel boring machines are used for hard rock, while shield tunneling machines are more suitable for soft soil. The shield method is very flexible and automated. The immersed tube method was used to build the Hong Kong-Zhuhai-Macau Bridge. It involves sinking prefabricated tunnel sections into the seabed and connecting them underwater with great care. Taken to waterproof the joints, building an immersed tunnel is an intricate process requiring precision. First, a dry dock like a shipyard is created near the tunnel site. Engineers excavate a large rectangular water tank, ensuring the base is level and watertight. It is here that the tunnel sections are made. Inside the dry dock, steel cages form the tunnel structure. Concrete is poured into molds to create the section walls. After the concrete has dried, the tunnel sections are tested for quality. Engineers use cooling techniques. The sections are then equipped with systems such as water ballast tubes and equipment. Monitoring external surfaces are coated with a layer of polyurethane to make them waterproof. The ends of the sections are sealed with steel bulkheads and seals for ensure a secure connection after the sections are ready. The dry dock is flooded and sections are tested before to be transported and installed. Trench where the tunnel will be placed is carefully excavated using large dredges for rough work and smaller for precision excavations. The riverbed must be leveled to within 4 centimeters to ensure that the sections fit together perfectly. Then comes the part exciting, as it is to move and install the tugboat and anchoring rope sections. Carefully position the sections guided by advanced systems of navigation that guarantees accuracy. Engineers inject water into the sections to gently lower them into place and align them for connection. This phase requires high-level technical skills and teamwork. NCE installed. The sections are reinforced with gravel geotextiles and stone cages to protect against erosion. The interior is equipped with electrical systems, fire safety features, and smooth tracks meeting transport and safety standards. From dry dock to final installation, each stage of this tunnel construction demonstrates impressive engineering skill. The Hong Kong-Zhuhai-Macau Bridge Tunnel has not only overcome natural obstacles, but has also demonstrated China's ability to push the boundaries of engineering innovation. The Hangzhou Bay Bridge is not only one of the longest sea bridges in the world, but also an iconic marvel of engineering. At an impressive 36 kilometers long, it connects Ningbo and Shanghai. Two major cities in China's bustling Yangtze River Delta. What makes the bridge even more remarkable is its location in an area famous for its extreme tidal conditions. Made this part of the sea seemingly impossible for construction. However, through visionary design and cutting-edge technology, this once forbidden stretch of water was transformed into a thriving transportation route, cutting travel time between Shanghai and Ningbo by over 2 hours. The bridge not only improved connectivity but also spurred rapid economic development in the region. The bridge serves as a critical lifeline, allowing goods and people to travel between these economic hubs with ease and efficiency, fueling growth in one of China's most prosperous areas. The success of China's bridge-building efforts can be attributed to its expertise in using advanced materials and technologies. For example, the Hong Kong-Zhuhai-Macau bridge used a staggering 420,000 tons of steel, enough to build 60 Eiffel Towers. From design to manufacturing is a key factor in its global dominance during the construction of the Hong Kong-Macau bridge. Every component was produced within China, saving costs and reducing project turnaround time. The country's vast and varied geography, ranging from high plateaus to turbulent seas, forces engineers to create custom designs for each bridge, ensuring that each structure is perfectly adapted to its environment. But bridges do more than just connect two places, they act as catalysts for economic transformation. Take the Hong Kong-Zhuhai-Macau bridge for example. It reduced travel time from a tiring 3-hour ferry crossing to a simple 1-hour ferry ride. 30 minutes by car, significantly improving regional trade and tourism. Similarly,